Okay guys, so y is equal to f of x, and this is f of x right here. Find f prime of x. Or, I mean, also find f prime. I mean, it's the same thing. Okay, what do you guys want to do? Well, what you want to do is, since you call this equal to y, note that y is equal to cosine. Let me make this spread a little bit apart. This will make sense in a second while I'm rewriting it. I'm not just rewriting it for the sake of rewriting it like what most people do. That's what a lot of people do, is they just rewrite things over and over again without ever doing any math. But what you want to do right here is you want to take the log of this side and then take the log of this side. Why do you want to do that? You want to do it so you can use this rule right here, this really nice rule that makes everything easier. If you do this, if you take the log of both sides, then you can rewrite this guy as 7 over x log cosine 5x. And that's really nice. So now what you can do is you can take the derivative of both sides. So implicit, I'm going to write d diff, and I'll just write implicit diff. Right? You're taking the derivative of both sides, so if we take the derivative of this side, take this derivative of this side, it's not changing anything, right? You're just taking the derivative of both sides, so everything's logically consistent here. So then you'd see that the derivative of this guy, log of y, is just going to be y prime over y, and the derivative of this side, we'll write it as d dx, 7 over x log cosine 5x. And this guy we're going to focus on right now because this is going to be explicitly long. It's going to take a while. But we can make it easier by calling it different names. So we call d dx of, okay, we'll keep the 7x out by itself. So 7x. And then this log what? We'll call this log of h of x. Log of h of x. Yeah. Let's see. Okay. The reason why I'm calling this h of x, you'll see why in a second, but just to make our life a little bit easier. It's not really a fancy substitution at all, just the simplification to make our math easier. That's all I'm doing here. So, taking the derivative of this guy. So if we take the derivative of this guy, we can see it's product rule and a little bit of chain rule and stuff like that comes in. So y prime over y, again start here, that is equal to 7 over x need a bigger chalk. 7 over x multiplied by what? And take the derivative of this guy, log h of x, which will be h of x over h of x plus log h of x times 7 over x squared. So all I did here is I just applied the product rule and took the derivative of 7 over x, which is negative 7 over x squared. And the derivative of log of h of x is going to be h prime of x divided by h of x. This is all consistent and it should make sense. Now we just got to find h of x. So h prime of x is cosine 5 of x. So take the derivative of cosine 5 of x. What do we get? We get negative 5 sine cosine, no, negative 5 sine 5x. Okay, and then we just fill in the gaps here. Let me write that y prime is equal to, now I'm going to put the y on the other side, y, and then we get 7 over x. H prime of x is this guy. So this is negative 5 sine 5x. And h of x is this guy over here. Cosine 5x plus negative 7 over x squared. And then log h of x, which is the same thing as log cosine 5 of x. one parenthesis, and another. This is your answer here, but we need to define what y was. Y was this guy. So y, being that we have to write in front. So we get cosine. I'm not gonna, I got space, whatever. We got cosine 5 of x to the power 7 over x being multiplied by this whole guy over here. Sine over cosine, what is that? That's tangent, so we get negative. We have a 5 times a 7 as well, right? So we get negative 35 tangent of x divided by x. And it's not tangent of x, it's tangent of 5x. Then minus 7 over x squared. Right? And this guy right here, log cosine of x. Look at that. That's f prime of x. A lot of work, huh? A lot of work. I'm going to recap on what we did. So set this equal to some other variable. It could be y, call it alpha, whatever you want to call it. Just call it another variable. So if you do that, then you can take the log of both sides and you can use this log formula here. Then use implicit differentiation. And you just have to remember the product rule, then the log rule, and then the quotient rule. When you do that general product rule here, and there is a lot of derivatives here. That's why I recommend doing what I did here. Give something a different name for a second to make your math easier, right? I mean, you could just try to do it all in your head right here. I can't. I need to slow it down. So this is what I did, and this should be the answer you get right here. You may get a different answer where you kind of pull things out and factor it, make it look a little bit nicer. But there's no point doing that because if you're taking a test, you should not be trying to simplify everything as much as you can. You should be trying to put the best, most confident answer you have. There you go.